Hello and welcome to day 8 of Calculus in a Year. This is also the first day of Calculus 1, so all that we've reviewed thus far is pre-calculus and algebra topics, so we're finally venturing into calculus proper. So today we're going to be going over limits, and these next couple of days they're going to be focused on limits. Let's look at this function, y is equal to 2x squared. So when x is equal to 1, when x equal 1, then y is equal to, let's see, 2 times 1 squared, that's 2. So we see that right here. We plotted that point right here, 1 comma 2. However, we're not really interested in what happens at that particular point. We're interested in what happens as we get closer and closer and closer to x equals 1. So let's just plug in some values that are to the left of x equals 1. So as we get closer and closer and closer and closer and closer to x equals 1, let's see how the y values are. So when x is equal to 0.5, we get a y value of 0.5. That's pretty far off, but if we were to plug in 0.9, we're much closer. We're at 1.62 for y. If we plug in 0.99, we get a y value of 1.9602. And if we were to plug in a x value of 0.9999, we get really close. We get this number here, 1.999, etc. So we get really, really close to y equals 2. So the limit as we approach x equals 1 from the left is 2, because we're getting closer and closer and closer and closer to 2. Now let's look at the limit as we approach x equals 1 from the right side. So that's going from here. Let's see, if we were to plug in x equals 1.5, we get a y value of 4.5. That's pretty far off, so let's try plugging in x equals 1.1. We get a y value of 2.42, so that's much closer. If we were to plug in 1.01, we get 2.0402. And if we were to get really, really close to x equals 1 from the right, and we plug in 1.0001, we get 2.0004, etc. So we get really, really close. And so the limit from as we approach x from the right, it's also equal to 2. So let's note that down here. Limit, write it like this, lim, as x approaches 1 from the left side, we put this negative sign right here to demonstrate that it's coming from the left side. It's equal to 2. And the limit, we approach 1 from the right side, we put this plus sign here to show that it's the values we're plugging in is greater than 1. If you're to plug in values that are greater than 1 and you're approaching 1 from the right side, you approach a y value of 2. Let's look at this graph here. We have the function y is equal to x squared minus 9 divided by x minus 3. If you plot that into this graph, you get a straight line, and it's continuous at all points, so there's a value at all points, except at this point here, when x is equal to 3. And the reason for that is because if you were to plug in 3 for this function, you'll be dividing by 0, and that's a big no-no in math. You cannot do that. So this function is undefined at the value of x equals 3. But let's see what happens as we get closer and closer to x equals 3. We approach from the left. If we were to plug in, say, 2.9 for x, we get 2.9 squared minus 9 divided by 2.9 minus 3. That's equal to 5.9. If we you were to plug in 2.99, you get 5.99. So we're getting closer and closer and closer to a y value of 6. So the limit, as x approaches 3 from the left side, is 6. Now let's look at the limit from the right. So as we come in from this way, the limit from the right is, let's see, if you were to plug in 3.1 for x, you get a y value of 6.1. If you plug in 3.01, you get 6.01 for y. So that means the limit from the right is, we intuitively know that the limit from the right is equal to 6. And since the limit from the left side is equal to the limit from the right side, then the limit as x approaches 3 is equal to 6. Now, this is not a super mathematically rigorous way of finding a limit. We won't get into the mathematical rigor of finding a limit precisely, but I just want to help you build intuition around limits. So that's why we're using this method to find our limits. Now let's look at an example where the limit fails to exist. So here we have this graph here. And it's a piecewise function. So we have a value of 4 if x is greater than or equal to 3. So this line over here. And we have we have a y value of 4 if x is greater than or equal to 3, and we have a y value of 2 if x is less than 3. So once again, we have a y value of 4 if x is greater than or equal to 3, and a y value of 2 if it's less than 3, if x is less than 3. So here's our graph, and we see that at x equals, when x is 3, we have y value of 4, and when x is, so x is equal to, when x is 3, we have a y value of 4. So what would be the limit as we approach x equals 3 from the left side? Let's see. We have a y value of 2 as we come from the left side. See, it's always going to be y equals 2. That's why our limit as x approaches 3 from the left side is equal to 2. Now what is the y value that we approach as we get closer and closer to x equals 3? Let's see. Over here it's all y equals 4. So that means our limit as x approaches 3 from the right side is 4. Now, what would be the limit as we just approach 3? Well, since the left-hand limit is different from the right-hand limit, then the limit does not exist. So I wrote DNE, that stands for does not exist. So the limit as x approaches 3, it's just not there because we have a different limit from the left side and a different limit from the right side. Now, let me ask you one question. What is the y value at the point, what is the y value at x equals 3? So we see that f of 3 is equal to 4. So when x is equal to 3, we get a y value of 4. So what I want you to understand is, just because the point exists, just because there's a y value at the x point, for a certain value of x, that doesn't necessarily mean that the limit is going to be there. So we see that even though there's a x is equal to 4, when x is equal to 3, y is equal to 4. And so even though that exists there, the limit does not exist. So it's almost like the reverse of the problem we had previously. So previously, we had this. So the limits existed, but the point did not exist there. In this case, the point does exist. We have the point 3, 4. the limit does not exist. Now let's look at another interesting problem. So we have another piecewise defined piecewise function. Let's see. When x is not equal to -4, we get a y value of 1. But when x is equal to -4, we get a y value of 5. So let me ask you, what is the limit as x approaches -4 from the left side? So as we come in from this way, what is the limit? We approach, or actually in this case, well, we approach y equals 1. In this case, we have 1 as our y value, always. So our limit as x approaches -4 from the left side is equal to 1. What about when we come in from the right side? The limit as x comes from the right side is also y equals 1. So we have that right here. So let's see. What is the limit? I'll cover up the answer. What is the limit as x approaches -4? Let's see. If the limit from the left side is 1, and the limit from the right side is also 1, then that means since the two limits are equal, then the limit as x approaches -4 is 1. So we have a limit here. Now, what is the function value? So what is the value, what is h of 4, because our function is h. What is h of 4? What is h of 4? So that's my question. H of 4, what's that equal to? It's right here. It's the point 4, 5. So here's our answer. So we have the limit from both sides and also the point. We also have the point. It's there too. But the limit, the value of the limit is not necessarily equal to the value of the point. So that's what I want you to, your takeaway is that sometimes the limits exist but not the point, and sometimes the point exists but not the limit, and sometimes both the limits exist and the points exist but they're different. And other times the limits exist and the point exists and they're the same. So just remember that. Now here's a problem that I want you to do on your own. So just one problem for today. I want you to determine the limit as x approaches -2 from the left side. And then I want you to determine the limit as x approaches I'm so sorry, I meant to write +2. Fix that. Alright, so I want you to determine the limit as x approaches +2 from the left side, and the limit as x approaches +2 from the right side, and then just find the limit as x approaches 2. And I also want you to find the value of the function at 2. And so here's our piecewise defined function. So please try this out on your own. Pause the video, and I'll unveil the solution soon. Alright, so here are the solutions. So to problem A, the limit as x approaches 2 from the left side is 4. The limit as x approaches 2 from the right side is 1. And since these two limits are different, the limit just does not exist because the limits from the left and the right don't match. And finally, the value of the function at 2 is equal to 3. So you can see that over here. As we approach from the left side, we get a y value of 4. And as we approach from the left side, we get a y value. Let me repeat that. I'm so sorry, I screwed up. As we approach x equals 2 from the left side, we get a y value of 4. As we approach x equals 2 from the right side, we get a y value of 1. And then the value at the point x, the value when x is equal to 2 is 3. So, thank you for watching, and I hope to see you back soon.